Welcome to video 10.4e, a common tangent problem. All right, there's a 5-step procedure. If you want to pause the video and write down these steps, I'll go through them step by step when I solve the problem. All right, here's example 4. A circle with radius 8 is externally tangent to a circle with radius 18. Find the length of the common external tangent. So now we need to know all those vocabulary words I went over before. So let's start with a picture. All right, so I've got, I'll say a larger circle here, and then I've got a smaller circle here. And I want to find the length of the common external tangent. So what I'll do is I'll just draw in, to the best of my knowledge, a common external tangent. So that's what I'm trying to find. Okay. Well, let's go through the 5-step procedure. I'll check it off as I go. By the way, this is a classic problem. It ranks up there with the walk-around problem. You'll for sure see it on a quiz and a test. All right, draw the segment connecting the centers of the two circles. Done. Draw radii to the points of contact and mark right angles. And let me make one more note. Make them parallel, the radii, otherwise it doesn't look good and you can't figure out what's going on in the rectangle. So I've got this, they seem to be somewhat parallel. So once you do one, kind of do the other such that it's parallel. And right away, mark the right angles. I always do that immediately so I don't get right angle confusion. Okay, step 2 is done. Step 3, through the center of the smaller circle, draw a line parallel to that common tangent. So here's the smaller circle. Let's go parallel to that common tangent. And again, let's mark those right angles. And if I got a right angle there, I have a right angle over there as well. Again, to avoid right angle confusion. That's a big source of mistakes and problems when students are doing it. Okay, step 4. Basically observe that we formed a rectangle and a right triangle. Okay, I've observed that. Step 5, use the Pythagorean theorem to solve this problem. Okay. So what I'm going to do is call this x here, and once I get x, then I've got the answer because I got a rectangle. Opposite sides of a rectangle are congruent. All right, let's start labeling with the information I was provided. The small circle has a radius of 8. We'll use a different color marker. Well, if I'm 8 there, I'm also 8 there. Again, opposite sides of a rectangle are congruent. Oh, the larger radius was 18. Well, if I'm 18 there and 8 there, that must be 10. Okay. Ooh, this radius here is 18, and that radius there is 8, making this whole dimension be 26. I now have a right triangle, and I've got two sides. I can certainly find the third using the Pythagorean theorem. So let me recopy that right triangle just so you can better see what's going on. So I'll do that below. Something like that, perhaps. So I've got a 10 there, a 26 there, and an x there. And once I solve for x, I'm done. Oh! Notice that this is the hypotenuse. I'm thinking of a 5, 12, 13 Pythagorean triple. Let's multiply it by 2. 10, 24, 26. I've got a 10 as a leg. I've got a 26 as a hypotenuse. So the other leg being 24 makes perfect sense. So x is 24, which means that that common external tangent is 24. If I did not have a Pythagorean triple, I would use the Pythagorean theorem. Leg squared plus leg squared equals hypotenuse squared. So there you have it. How to do the 5-step procedure for the common tangent procedure to solve a classic problem.